Uh, the last function I have to talk about here is the struct command. Again, vector and struct. This will be familiar if you've worked with Unican, and if you watch our Unican webinar we did last week, you'll remember that Unican protocol is very good at sending information between Unitronics controllers, but we can say it's limited to sending strictly memory integers. Now again, as we pointed out, this isn't really a limitation. If you consider Modbus, if we want to get mixed data, a memory bit, a memory float, and a memory integer, there's three separate commands. But if we package or struct our information into one register type of a vector, we can send multiple pieces of information in a single command. So this cuts down on time it takes to transfer information, and it cuts down on transmission overhead in general. So let's take a look at the struct command. The struct command is going to do two things. It's going to operate in the struct fashion or in the extract. The parameters we have here, from vector to mixed data locations or from mixed data location to vector. What we're going to do in this first struct is take mixed data and create a vector starting at MI500 with the information listed below. So I'm going to gather memory integer 300. If we look on the right side, we have a column for length. This is the amount of memory integers I'm going to take. Again, this can be considered a vector. We're going to use MI300 and sequentially 301. We're going to take MB300 with length 4, so that means MB300, 301, 302, and 303. Memory float 30, 31, and 32, and double word 30 and 31. Okay. So the important part of this function block is we have to remember the structure we define here. We're using this and we're building a vector at MI500, a memory integer vector, and we're going to store it in 500. We can then send the vector starting at MI500. If we look at the bottom, total bytes is 25. So if we round to the nearest or the highest close even number, that's going to be 26. So we'll have 13 memory integers. If we remember, we can store 2 bytes to an MI, but we can't really say we have half of an MI, so we're going to round up. This is going to be 13 memory integers, a vector with length of 13. So MI500 with length of 13. We can send that. We can send all these different types of data with one single send command. Okay, so if we remember the structure here, we hit OK. We look at the extract now. We want to see that we have the same structure defined from, in this case, it's the same source address because we've saved it into the PLC memory. We're now going to read that back, but we're going to save it to different locations. So what's important here is the operand type and the length. If we put these operands out of order and we change the lengths, we won't read this information back in the same way we've created it. So we're going to save our memory integers now to 302 with length 2. Our memory bits to 304 with length 4. Our memory floats to 33 with length 3. And our double words to 32 with length 2. Okay, so let's go online and let's watch if this works. I'm going to use the workspace I have under watches now. We see that in our online mode, the value of MI300 is 123. MB300 is set. Memory float 30 is 123.456. Double word 30 is 1234532. Make this a little bigger. When I run the struct, we've converted all this information and we've stored it in the vector at MI500. Again, if we want to, I want to look at it here. We've created this vector here of information. If we go back to our watches, we run our extract. We've written all of our information to the new registers. So we should expect to see that these are the same. We took mixed data, wrote it to a vector in MI500 here, and then we took the information from MI500 and wrote it back to mixed locations. So now MI302 is 123, MB304 is set, memory 33 is 123.456, and double width 32 is 1234532. So the extract should work. It should pull out the information exactly as it was stored, but again, it's important that these operand types and their lengths be defined exactly as they were in the struct command. Okay, so these are some of the vector tools we have. Again, some of the most basic. Notice there's a couple more that can be found in the help, or if you have any questions, you can, of course, send us an email. These are the basics of working with vectors. Again, one of the most powerful tools we have available is a data table for storing and saving information. If we have to work with the information, we do have to pull it back into the PLC. So using the read and write column tool is very helpful. Another very important topic that we've covered here is this indirect write. Again, what we're saying here is we're taking from our A the value that's in MI23. Let me just set this one again. The value that's held in MI23, and we're pointing to the memory integer to write it to. So MI25 is holding the memory integer to write to. If we set it again, we're writing to memory integers based on that value. Okay, so that's about all I have to say for this webinar with these examples. Thank you all for listening. Again,